Hello everyone, thank you for joining me in today's virtual presentation at BIM Coordinators Summit. I'm very happy and excited to dive into the topic, navigating the landscape of digital twins in the construction industry. Before we go ahead with the presentation, let me introduce myself. I'm Nasibaunnisa. I'm an architect, a digital construction specialist, and a construction technology consultant. I help companies enhance their workflows and leverage technology for a sustainable tomorrow and better ROI. I help companies mainly in Asia Pacific and North America to enhance and train on digital construction knowledge. Over the past 7 years, I've gained an extensive experience in the construction industry, both in design and digital construction. My area of expertise lies in building information management, coordination of digital twins, and reality capture technologies, streamlining construction processes through digital tools. I'm extremely passionate about digital construction because I truly believe it's the future of the industry, and my goal is to help companies transition to smarter workflows, improve their ROI, and deliver more efficient projects. Before we dive into the presentation, I'd like to give you a quick overview of the topics we'll be covering today. This will help you guide through the key points we'll discuss on digital twins in construction. We'll start by explaining what digital twins are and how they are transforming the construction industry, particularly in terms of real data and virtual simulations. Next, we'll explore the current level of adoption of digital twins across the construction sector, including which regions and companies are leading and where the gaps are. Then we'll dive into the key benefits of adopting digital twins, from improved decision making and efficiency to sustainability and lifecycle management. We'll also look at challenges that are preventing widespread adoption, such as high costs, compatibility issues, and the skill gaps. After understanding these challenges, we'll ask ourselves the big question: is the industry ready for digital twins? We'll assess the readiness from both technology and skill perspective. We'll then outline steps that companies can take to get ready for the digital twin revolution, including technology investment and upskilling workforce. Finally, we'll wrap up with conclusion that ties everything together, summarizing the key takeaways and offering insights on how to move forward. So let's get started by taking a closer look at what digital twins are and why they're becoming so important in our industry. Okay, let's start by defining what a digital twin is and why it's becoming so important in the construction industry. Now, before I go ahead defining what a digital twin is, I think we all know that it's a term that is being most argued upon in terms of not being able to define it very well, because it's a very vast sector and it's very difficult to define what a digital twin is when we get into the detail of it. But an overview of what digital twin is it's essentially a virtual model or replica of physical asset, process, or system, but it's much more than just a static model or a simple representation. A true digital twin mirrors the physical world in real time. This means it can capture data about the physical asset, such as its current state, performance, or even wear and tear over time. Examples in construction. In the context of construction, a digital twin could represent anything from a single building to a large infrastructure project like bridges, roads, or an entire district. For example, imagine a digital twin of a skyscraper where you can monitor the energy use of each floor, track the condition of elevators, or simulate how the building might react to an earthquake. This live connection between the physical asset and the virtual model is what makes digital twins so powerful. The power of digital twins. What sets digital twins apart from traditional models is that they aren't just static representation. They offer real-time monitoring, which means we can observe how buildings or infrastructure is functioning in real life. In addition to monitoring, digital twins enable simulation, allowing us to test different scenarios such as potential failures or environmental impacts without affecting the physical asset. Finally, there's optimization. By analyzing data from digital twin, we can make adjustments to improve efficiency, cut costs, or extend the lifespan of the asset. The key technologies powering digital twins. Well, there are several key technologies come together to make digital twins possible. First, BIM, Building Information Modeling. It forms the foundation of a digital twin by providing detailed, structured information about the asset. It allows us to visualize the design, structure, and materials of a project. This model usually contains all the flat data. Second, IoT, Internet of Things. IoT sensors are critical because they capture real-time data from the physical world. These sensors can track temperature, movement, energy consumption, and other variables, feeding that information into the digital twin. While IoT and BIM together make it a digital twin because this is where your flat information connects with the live information. Thirdly, artificial intelligence. AI helps us analyze the vast amount of data collected by the IoT devices. AI-driven insights can help predict maintenance needs, optimize energy use, and even suggest design improvements. And data analytics. With all the data flowing into the digital twin, we need robust analytics tools to interpret it. Data analytics help make sense of the information, turning raw data into actionable insights that improve decision making. Now, in summary, digital twins create a dynamic connection between the physical and digital worlds, giving us unprecedented insight and control over our projects. Now, let's take a closer look at where the construction industry stands when it comes to adopting digital twins. Pioneers versus the majority. While a few industry leaders are at the forefront, particularly in large-scale infrastructure and complex projects, the majority of companies are still at an early stage. The pioneers have already implemented digital twins to improve asset management, reduce downtime, and enhance decision-making with real-time data. These organizations are often the ones leading the way in terms of research and development in this space. Widespread use of BIM, but what about digital twins? Many firms are already working with BIM and static 3D models, which is critical at first step. However, they haven't yet transitioned to full digital twins, which offer real-time data and the ability to stimulate and optimize systems. Moving from BIM to a true digital twin involves integrating more dynamic, live data streams through IoT devices and analytics, which remains a significant barrier for many companies due to cost, complexity, and required skill set. Geographic variation in adoption. Adoption varies significantly by region. For example, in Japan, I've noticed a growing interest in integration of reality capture technologies such as cubics in open space with BIM models. These tools provide the kind of high accuracy data that can be crucial for developing digital twins, especially in construction projects where precision and real-time updates are essential. This shows that although digital twin adoption may not yet be widespread, there's a strong foundation being built in regions like Japan, which could soon accelerate their use across industries. Now, challenges slowing adoption. Despite these benefits, there are still several challenges to widespread adoption. These include high upfront cost. This is a big one. Digital twin technology requires investment in sensors, in cloud infrastructure, and software tools. The skill gap. Many teams don't yet have the technical expertise to manage or analyze the data generated by digital twins. Cultural resistance to change. Construction is an industry that has traditionally been slower to adopt new technologies, and there's still some hesitancy to embrace digital twins fully. While we've made some progress, the majority of the industry still has work to do before digital twins come to standard. One of the biggest advantages of digital twins is their ability to enhance decision making. By providing real-time data, stakeholders can make informed decisions much faster with more accuracy, whether it's during the design phase, construction, or even post-construction. Having up-to-date data allows us to optimize how we approach various tasks. Digital twins continuously pull in data from sensors, IoT, and connected systems on the construction site. This means managers, engineers, and owners can react to issues as they happen. For example, if there's a delay in material delivery, or an unexpected issue on site, the digital twin can show the impact in real time, allowing teams to adjust timelines or resources immediately. Instead of making decisions based on outdated or incomplete data, digital twins ensure you're always making a decision with the most accurate data at all times. Here are some more benefits of a digital twin: predictive maintenance to prevent major issues, increased efficiency by reducing errors and rework, time and cost savings, sustainability and energy performance analysis, long-term asset management. To summarize, the benefits of digital twins are clear. They help us make better decisions with real-time data, reduce downtime with predictive maintenance, improve efficiency by cutting down errors and rework, and ultimately save time and money and energy. Whether it's optimizing construction operations or ensuring long-term sustainability, digital twins have the potential to transform the way we work. However, despite the benefits, there are still several barriers to adoption. One major challenge is data silos. Many companies struggle to integrate data from different sources, making compatibility a key issue. Cost can also be a barrier, particularly the upfront investment is in technology and training. On top of that, there's a skill gap. We need more professionals who understand both construction and digital twin technologies. There's also a cultural resistance with some organizations, and a very big point, cybersecurity is an ongoing concern as we handle with more sensitive data. So, are we ready for digital twins in construction? From a technology standpoint, we're getting there. Technologies like IoT, AI, and BIM have already laid the foundation for digital twins. Many of the tools we need to build, monitor, and maintain digital twins already exist, and they're constantly improving. However, even though we're close from a technology perspective, the industry as a whole is not fully prepared to embrace digital twins. There are still significant gaps in digital skills, processes, and collaboration that need to be addressed. When we look at the global landscape, some countries and companies are leading the charge when it comes to digital twins, while others are falling behind. In regions like North America and Europe, we're seeing more projects that fully integrate digital twins, but in other parts of the world, adoption is slower and the readiness level varies greatly. To close those gaps, there's a strong need for more research and development in the digital twin technology. We need to continue innovating, not only in the technology itself, but also in how it's applied to the construction industry. Investment in R&D is essential to advancing the capabilities of digital twin. Another critical step is investing in training and upskilling the workforce. If we want digital twins to become a standard practice, we need to make sure that professionals across the board have the digital skills to work with technologies. We also need to rethink how we collaborate in construction industry. Digital twins thrive on integration and data sharing, so improving collaboration between different stakeholders like architects, engineers, and contractors, and facility managers will be crucial to fully leveraging the power of digital twins. So, while the technology is nearly there, the key to fully realizing the potential of digital twins lies in closing the gaps in skills, collaboration, and processes. This will require continued investment in technology, R&D, workforce training, industry-wide digital adoption. To wrap up from a technology perspective, we're close, but there's more work to be done on the industry side. By investing in skills development, improve collaboration, and continuing to push innovation, we can close the gaps and fully unlock the potential of digital twins in the construction industry. So, how can we prepare for implementation of digital twins? Let's break it down into 4 essential steps. Invest in technology. To lay a solid foundation of digital twins, we must invest in the right technology. This includes tools like IoT sensors, which collect real-time data, AI, which interpret this data to provide actionable insights, and cloud platform, which store and manage the data effectively. These technologies will enable us to create accurate and dynamic digital representations of our physical assets and environment. Second, upskill the workforce. Our teams need to be equipped with the skills necessary to handle digital twins technology. This includes training in digital processes, data management, and understanding how to leverage these tools effectively. By investing in professional development, we ensure that our workforce is prepared to utilize these technologies to their full potential and adapt the evolving digital landscape. Third, foster collaboration. Collaboration is crucial for driving innovation in digital twins. We should actively seek partnership with technology vendors who offer cutting-edge solutions and universities that are conducting advanced research in this field. These collaborations can provide access to new technologies, best practices, and innovative approaches that can enhance our digital twin initiatives. 4. Start small and scale up. Rather than jumping with a large-scale project, it's wise to start with pilot projects. These smaller scale initiatives allow us to test and refine our approach, measure the results, and identify any challenges or areas for improvement. By learning from these pilot projects, we can make informed decisions and gradually scale up our efforts to implement digital twins more broadly across our projects. By following these steps, we can effectively prepare for and implement digital twins, setting ourselves up for success. Now that we've come towards the end of my presentation, to wrap up, the industry is making progress, but we're not fully ready for digital twins just yet. There are still hurdles to overcome in terms of skills, culture, and technology. However, the potential is enormous, and if we start investing now in people, processes, and technology, we'll be well positioned to lead the way in the future. Now, I'd love to hear from you. What challenges or opportunities do you see when it comes to implementing digital twins in your projects? I would also love to connect with those who are interested in sharing knowledge or have any questions. I truly appreciate you watching my presentation virtually, and for those who are interested to stay in touch, at the beginning of the presentation I have a QR code for my LinkedIn. Please feel free to reach out, and thank you so much.